All right, so now that we've downloaded everything that we need and have oriented ourselves, we'll go ahead and get started setting up our first trial and then go on to conduct that trial. Go ahead and take a moment to verify the integrity of all of your electrical connections on your device. Also make sure that the battery is plugged in, but that the power is off. So now we'll look at some of the parameters that'll be plotted, so that way we can have a better understanding of what's going on in the GUI. And so we'll go ahead and bring up VS Code. All right, so with Visual Studio Code open, go ahead and go to your Explore tab and then Open folder. And then here, just find your OpenExo folder and then go into your Exocode folder and then into SRC. Just open that SRC folder. And you can see we've got all of the Exocode files here. We'll go down to uartcommands.h. This is where the plotting parameters are defined. So we'll go down to about line 350 is where the plotting parameters begin. And you can see here, we've got some comments here which define what exactly is getting plotted and where. And you can see we've got tab 1 and tab 2. In the GUI, we've got two different plotting windows. Tab 1, you've got two graphs, one for the left side, one for the right side. And then in addition to the two graphs, you've got two plots on each graph. And so you can see that here within tab 1, we've got top blue line, top orange line, bottom blue line, bottom orange line. So you could think of this as left top line, left orange line, right blue line, right orange line. And then you've got the same thing for the second tab. And to show you what that actually corresponds to in the GUI, I'll go ahead and open up the GUI. You don't need to on your part. We'll do that later, but this is just so you can see kind of what's going on with those plotting parameters. So you can see here we're in, when you first open up the GUI, you're in the first tab, and you can see data 0 and 1, and then data 2 and 3. And if we go back into uartcommands.h, you can see 0, 1, 2, and 3. And in the first tab, 0, 1, 2, and 3. And then if we switch over to the second tab, and I've got a little bit of noise here because I don't have certain pins connected at the moment, but you can see data 4 and 5, and then data 6 and 7. And then going back here, you see data or tab 2, 4, 5, 6, and 7. And so that's kind of what those correspond to. And then you can see we've also got parameters 8 and 9. These parameters don't get plotted in the GUI, but they'll save to a CSV file. And then where that CSV file gets saved is actually within your OpenExo folder. So I'll go to mine. And then here, if we go to the Python GUI folder, you'll see I've got two CSVs here from trials that I've conducted. This is where all of the data that gets plotted, as well as those parameters 8 and 9, which don't get plotted, that's where all of those get saved. They get saved into a CSV file. That way you have access to that data. You can manipulate it, save it, do whatever you want with it. And then going back into some of the plotting parameters, that's the guide for what gets plotted and where, and kind of the general logic behind it. And then we're going to be running the step controller on the HIP configuration, or the bilateral HIP configuration of OpenExo. And so you'll see we've got a switch case down here, and you can see each case corresponds to a different joint configuration. So you can see the first one as bilateral ankle, and you can see some more comments here to give you some more orientation for where those parameters get plotted. So we've got bilateral ankle here, and then bilateral hip is what we're going to be interested in because we're using the bilateral hip configuration. And then you'll notice this comment up here actually that says the ankle and hip are configured for the step controller, which is what we'll be using. And then elbow is configured for elbow min max, multi-joint for their primary control schemes. But again, we're concerned with bilateral hip, so we'll go ahead and take a look at this. And you can see parameter 0 is filtered torque reading. Parameter 1 is feed forward set point, and feed forward set point is the torque prescription that the controller we're using will give to the exoskeleton. And so since we're using the step controller, the feed forward set point is calculated by the step controller. If we were using a different controller, such as Franks Collins, it would be calculated by the Franks Collins controller. But you can see 0 and 1 correspond to filter torque reading and then feed forward set point. 2 and 3 correspond to filter torque reading and also feed forward set point. And then if we go back up here, you'll see that all of those will get plotted in tab 1. And the filter torque reading parameter is more for if you're using torque sensors. We're not using torque sensors, so we just won't get a plot for that. But what we will see is this feed forward set point here. And then in addition, you can see that once we get into the second tab, we'll start getting percent gate, toe FSR, percent gate again, and then toe FSR again. Those are more for the Franks Collins controller and are not going to be relevant to us. They're not going to get plotted. If they do get plotted, it'll probably just be noise. So we won't, for our first trial, be concerned with the second plotting window. And then also you can see we've got some parameters here for parameter 8 and 9, and that's just going to be heel FSR and heel FSR for the respective sides. And again, these parameters correspond more to the Franks Collins controller, so we won't get anything. If we do get anything, it'll just be noise, but you'll be able to see that that gets saved into the CSV file. And then regarding those CSV files, they get saved regardless of whether you manually end the trial with the button in the GUI or turn your device off or it loses power or you lose connection, anything like that. Anytime you conduct a trial, all of the parameters you have set here will get saved into that CSV regardless of what happens. Before we move on, an important thing to note is that the first time that you load your SD card into your computer or plug it into the Teensy, it's going to be empty. So what you're going to need to do for your first time loading your SD card is go into your OpenExo folder and then go into the SD card folder. And then within that folder, just take all of the files in there and then copy them over into the SD card. And then another important thing is that anytime you want to modify the parameters that the exoskeleton is using, you want to be sure that you are modifying the actual SD card itself, not the folder within Exocode. So now we'll go ahead and get the SD card configured for our first trial. So take the SD card out of the Teensy and plug it into your computer. And wait for it to load in. There it is. And in the SD card, first we'll go into config.ini. And so you can see here we've got some of our main configuration information. Right here we've got this board parameter. This needs to be set in config.h. This one there's a little bit of special handling that this one has. But provided you're using the AK series of motors, you likely won't be changing the board version. This is more for if you're using the Maxon motors or an older AK board version, older than the version 0.5.1. And so again, we'll cover that once we go through some of the configuration info here in config.ini. And so you can see here we've got this EXO parameter. This is the configuration of OpenExo that we're using. So you can see it's set by default to bilateral hip. This is provided you follow the build guide up to this point. This is the configuration that you will have wound up with. If you built the Bowden transmission system and built your own end effector for that transmission system, you may then want to change it to bilateral ankle or bilateral hip ankle. But for now, we'll keep this as bilateral hip. If you were to change it to bilateral hip or bilateral hip ankle, you can find those parameters or find those configurations down here. You can see we've got bilateral hip ankle, and within here it's got its own configuration info, and then same with bilateral hip and then bilateral ankle. But again, we're using the bilateral hip configuration, so we will go down to bilateral hip, which is right here. You can see we've got an option to set which side of the exoskeleton we're using. We can use left, right, or bilateral. We're using bilateral, so we'll leave it set as that. And then these are the joints used in this exo configuration. We're only using the hip joint, and you can see this is also where we set the motors to be used for each joint. Because we're only using the hip joint, and we're using, at least in my case, the AK60 V1.1s, which again, provided you follow the build guide to a T, those are the motors that you're using. But since we're using the hip joint with the AK60V 1.1 motors, we'll go ahead and set hip equal to AK60V 1.1. And you can see the spelling and capitalization is going to be the same as used in these comments. So we'll go ahead and save that. And then we'll go down to here, and you can see we've got some gearing ratio information. We're not going to be changing any of this. It's just the internal gearing of the motors. And then here we can set the default controller for each respective joint. We're using the hip controller, and so we'll set this, and we're wanting to use the step controller. So we will set this to step, and you can see that we can find that in these comments up here. And again, the capitalization and spelling is going to be the exact same as in the comments. So we'll go ahead and save that. And then here you can see options for using torque sensors. We're not using torque sensors. Flipping motor directions, we can do that here. Flipping directions for torque sensor readings, again, we're not using torque sensors. And then here we can flip the direction for angle sensor readings. We're not going to be doing that at the moment. And then here you can set joint range of motion limits, but we're not going to be changing any of those. And then here, again, this is more torque sensor information, which we are not using. And so going back to that board parameter up here, you can see it says it needs to be set in config.h, and then it gives you some instructions for actually changing that parameter. So we can go into our exocode folder. We'll go into exocode, src, open this folder. Then within here, it said config.h, so we'll find config.h. And then right here, you can see we define which board we're actually using. And so again, provided you follow the build guide to a T, this is the board that you will be using. The most likely reason you would want to change it is if you're using the Maxon motors, in which case you would change this definition right here. You would change AK board V0.5.1 to be AK board V0.6. Maxon. But again, this is assuming you follow the build guide to a T, so we'll leave the board definition as is. And then just make sure you save everything before you exit out, and we can leave the config file. And then here you can see we've also got folders for ankle controllers, elbow controllers, hip controllers, and knee controllers. We're concerned with the hip controllers, so we're going to go into this folder here. And here you can see we've got some of the different controllers for the hip configuration. We've got the chirp controller, constant torque, Franks Collins, and so on. Notably, we've got the step controller right here. So you've got your main EXO configuration information right here in the config file, but within these separate folders you have more specific parameters that you can set for the individual controllers. And so here you can set like the torque magnitude, whether or not you want to use PID control, and then you can tune the PID parameters. So we'll go ahead and go into the step controller configuration file. Then we'll open with Excel. And here you can see we've got amplitude, duration, repetitions, spacing, PID, so on. As a little bit of orientation, the two numbers right here define some of this one defines how many rows will be ignored, and then this one defines how many parameters you actually have. So it essentially just tells the exoskeleton how to read the config file. But looking down here, we've got an amplitude of 1, and this is in Newton meters. So we've got 1 Newton meter of torque. Our step duration is currently set to 2, but I will set that to 4 for now. That way it's just a little bit longer. Repetitions, I'll set to 5. So that's how many times it will go through torque on, torque off, torque on, torque off, so on. Spacing, I'll set also to 4. That way the duration of the torque and the spacing between torques is the same, and then we're not using PID, but if you wanted to use PID, here are the parameters that you can tune for that. And so now we know that we're going to be getting 1 Newton meter of torque for 4 seconds, and then a 4-second rest, and then another 4 seconds, and that'll happen 5 times over. So we'll go ahead and save this, exit out, and then we can eject the SD card and put it back into the Teensy. Alright, so with the SD card updated, we'll go ahead and upload the EXO code to the exoskeleton. To do so, just go ahead and plug in the Teensy to your laptop. And we'll start with the Teensy and then we'll upload the code to the Nano. But anytime that you are editing any of the code that's in either exocode.ino or SRC, which is the more likely one you'll be editing, anytime you edit any of the files in here and want that change to take effect in the exoskeleton, you're going to need to go through the process that we're about to do. So, now that you're plugged into the Teensy, we'll go into exocode.ino, which again is the conductor of everything. And from this file, we will make sure that we have the Teensy selected, and then we'll press upload. And we'll wait for it to compile and upload. And you can see we got an error. This happens if the Teensy loader didn't start before you tried uploading code. And so the easiest fix is just to start uploading again, and you can see that the Teensy loader is now running. So now when we try again, it should successfully upload. So you can see the upload completed successfully. Now I'm going to walk you through how to troubleshoot errors if maybe that upload didn't work after the Teensy loader had started. So to do so, I'm going to simulate an error by going into the EXO code. And then, for example, I'll go into the file we had looked at before, uartcommands.h. And just to simulate an error, let's say in here I accidentally add something and it's just the word 5. And then we'll go ahead and save that. Then go back to Arduino, upload again, and I should get a compile error. And you can see here it says compilation error 5 was not declared in the scope. So assuming this is an error that you weren't expecting, you might be a little bit confused as to where that error might be coming from, given how many files there are and how large those files are. So one thing you can do to easily troubleshoot errors is go down here where it says compilation error 5 was not declared in the scope, highlight the word error, and it will show you all of the instances of that word on the right side of the screen right here. And so we'll scroll up and look through each of these and see if they correspond to anything that we think might be the issue. And you can see here in file included from the directory, and then error types.h 14. It's not really what we're looking for. Error manager, not what we're looking for. Error types, not what we're looking for. And you can see right here it says uartcommands.h line 358. We've got an error and it says 5 was not declared in this scope. And so from there we could then go back into uartcommands.h, get there really fast. And it said line 358, so we'll go down to line 358, and you can see line 358, 5, and there's no declaration for it. And so we can then troubleshoot that and say, oh, that's, I accidentally put that there, let me just delete that, save, and we should be good to go. We'll try uploading again. And you can see it was successful this time. So anytime you run into unexpected errors like that, it's good to try to highlight the error in the output window and then search through the mentions of error to try to find the source of it. And so now that we've got the code uploaded to the Teensy, we can move on to uploading code to the Nano. To do so, same process, just unplug from the Teensy and plug into the Nano. The reason we upload to the Teensy first is because it's typically a little bit faster to upload to the Teensy, and so if there are any errors, it's just faster to catch those errors that way. But now that we're plugged into the Nano, we'll go up here and select the Arduino Nano 33BLE and simply press upload. All right, and you can see it was successful that time. Now that we have the code uploaded to the Teensy and the Nano and the SD card is updated, we are ready for our first trial.